The carbon to nitrogen mix, you want, as I said, ideally 3 parts brown, 1 part green. Okay. If you have a lot of browns, it will be slow. What you can do is you can shred in order to increase the speed, and you can add some water. Okay. If you have a lot of greens, then it's gonna stink, rot. It's gonna rot. Okay. And flies will develop. Okay, you want to avoid that by shredding your greens and adding some browns to it. If you don't have browns, you should buy some compost. Okay, already made. Try to get a vegetative compost. Okay, and cut your browns, your greens, and put them inside a pile. You start to build, or use newspaper. Okay, shred newspaper. Okay, so you should cover your greens in order for it not to smell or develop flies. Okay. Now the humidity. Okay, if you have a lot of water, it will stink and it will be anaerobic. You want to avoid having a lot of humidity. Now, if you just have a little bit of water, it will not decompose because microorganisms need water. I'm giving you the extremes, and more likely you want to be about 50% humidity. I'm giving you the extreme so you can sort of understand the effect. Now, it should be humid but not wet. And what you do is that you make a hole in your compost, you fill it if it's warm, you draw a sample in your hand and you squeeze it. If you see some drops coming out, it's probably too wet. If you feel it's wet, okay, but you don't see any drops coming out, you are more likely okay. Okay. Aeration, okay. If you have little air and you have a lot of humidity and you have a lot of greens, it will stink. Okay, an aerobic compost never stinks, meaning a compost that has air and oxygen will never stink. Okay, if your compost is stinking, it means it doesn't have a lot of air and it has a lot of greens, more likely. Okay, particle size. If it's small, it will compost fast. Okay, unless it's like really powder small. If it's powder small, then it might become anaerobic. Okay, and you want to avoid that. Okay, if it's large, it will be slow to compost. Let me give you an example. Here we have grass on the left and bread on the right, and of course the grass will decompose faster than the large loaf of bread unless you shred it. Okay. Now, temperature, if it's hot, more than 100 to 140, it's composting. Okay. If it's warm, less than 100, it's slow composting or is finishing up. Okay. If it's cold, okay, it's very slow or is already composted. So you can see here how temperature can help you, understand on, where you're about in your compost process or what is happening where your compost. And typically a compost curve in temperature looks like this over time. Here we have temperature on the left side and composting time on the bottom. Once you do your mix, if it's proper, it will increase in temperature rapidly, probably after 1 day up to 140. You want to keep it there for a few weeks, and then it will decrease with time. Now that's the typical curve. What could happen is that you're going to see peaks and valleys if you record this temperature. And that could happen because, let's say, your temperature increases to 140 degrees and your water evaporates. Once your water evaporates, there is not enough water for microorganisms to work and your temperature drops. Now you add some water and your temperature increases. Okay? So you can see how temperature is an important factor and is easily monitored that can show you if your process is going properly. Okay. Now, here for example, in coffee pulp, we typically reach a temperature of 120 degrees. We could reach a temperature higher than that if we have a mixture of coffee pulp to wood chunks or wood chips, which is higher. In this case, we use 3 parts coffee pulp and 1 part wood chips. We want to have as much coffee pulp as we want because we need to bring the wood chips from some other place. and so we want to avoid bringing the wood chips from other locations. Okay. Now, once you're done, you want to use a metallic mesh and recompost the top part and use the screen part. So the upper part you are going to put back into your compost as bulking agent, and your lower part is what you will use at home, okay, and your garden. So you can use to grow your vegetables or grow some flowers. Okay. Now let me give you an example of a little bit when you have a lot of material. One technique you can use, these are PVC pipes, 4-inch, 4-inch on diameter and 10 feet long, and we drill some holes about 2 inches, 1.5 to 2 inches in diameter every foot at two sides, and we put the material on top, as you can see here, and basically that is what you get once you're done. And this is what is called a passively aerated static pile. Basically, you create a chimney effect. Once your material is heating up, you create a chimney effect that aerates your material without having to move it. Okay. So this is more if you have a lot more material, then you would use this. If not, you would use the other methods that you saw before. Okay. This is a picture of the agriculture experiment station in Adjuntas. This is a greenhouse. It's newly built. On the left side, you see some tomatoes growing, and on the right side, you see some experiments going on different feedstocks. Feedstocks are the different mixtures of materials with coffee pulp. On the center, you see some clays and some compost from different parts of Puerto Rico.